haloarenes are insoluble in water because of they are the non-polar compounds. Okay, non-polar compounds are highly soluble in non-polar solvents only. So what are the examples of the non-polar solvents means here? So carbon tetrachloride, benzene, okay, and CCl4, higher alcohols, higher ethers and all here. Okay, and we are discussing about the boiling point temperature. The surface boiling point temperatures are depends upon the surface area. If the surface area is going to be increases, their boiling point temperature also is going to be increases. Okay, and melting points also we had seen for the haloarenes also. Now we can see about the density. So density. So actually how we can represent as a density? Density. So how we can explain as a density? So generally density is nothing but mass by volume only, na? So density is nothing but here mass by volume. Okay. Now according to that one, what we can say mass is going to be increases means the density also is going to be increases. Now Aditi also she's getting same problem also. Right. So density is depends upon here mass. Mass is going to be increases means here the density also is going to be increases. According to that one, if you see means we have a different types of the alkyl halides here. For example, methyl fluoride is the CH3F, methyl chloride CH3Cl, methyl bromide CH3Br, and methyl iodide CH3I. Okay, so methyl fluoride, methyl chloride, methyl bromide, methyl iodide. So which one is having the high density? Which one is having the high mass? Greater the mass. Either methyl fluoride, methyl chloride, methyl bromide, methyl iodide. As per that one, density is directly proportional to the mass, inversely proportional to the volume. So mass is going to be increases, means density also is going to be increases. According to that one, which one is having the greater the density? That is my question.
Sir, is it CH3I?
CH3I here.
So
Okay.
CH3I.
CH3I is having the greater the density. From fluorine to methyl fluoride to methyl iodide, density is going to be increases. Methyl fluoride to methyl iodide density is going to be increases. Why the density is going to be increases means because of mass is going to be increases. And dipole moment here. Dipole moment. Dipole moment. So generally dipole moment is depends upon the electron negativity. If the electron negativity is going to be increases, means the dipole moment is going to be increases. Okay, dipole negative electron negativity is going to be increases means that dipole moment also is going to be increases. But it is not happening in this one here. A small change it is that. Sir, according to that one, which one is having the greater the dipole moment means CH3 Cl is having the greater the dipole moment than that of the CH3F. After that, CH3Br and then CH3I in here. Okay, so which one is having the greater the dipole moment value means here? So methyl chloride is having the greater the dipole moment. Which one is having the greater the dipole moment here? Methyl chloride is having the greater the dipole moment than that of the methyl fluoride. After that, methyl bromide. After that, methyl iodide. Okay, so generally, which one we can expect means here from methyl fluoride to methyl iodide dipole moment is going to be decreases. In this one, small change here. Okay, small change. So Y means here greater the electron density, smaller the size and greater the electron density it will be there here. Okay, so that's why it is reduced here. And if you see haloarenes, haloarenes means we have a different types of the haloarenes. What are the different types of the haloarenes are here? So 1,2 dichlorobenzene and here 1,3 dichlorobenzene, 1,3 dichlorobenzene and 1,4 dichlorobenzene. 1,4 dichlorobenzene. Okay, so out of these three, which one is having the greater the dipole moment? Either 1,2 dichlorobenzene, 1,3 dichlorobenzene, 1,4 dichlorobenzene. Which one is having the greater the value?
So
So
the
which
first one?
the first one is having the greater the value after that second one. Okay, I think so. This concept you may study it in chemical bonding chapter.
Yes, sir.
Okay, so we may study it in a chemical bonding chapter. Sir, how we can define the dipole moment means in polyatomic molecule. In polyatomic molecule, dipole moment can be represented as a mu mr, resultant dipole moment. How we can calculate the resultant dipole moment means, so mu r is equal to mu1 square plus, so mu2 square plus, so 2 cos mu1 mu2 cos theta, 2 mu1 mu2 cos theta. So by using this formula, we are going to calculate the dipole moment. Okay, so 2 mu1 mu2 cos theta, mu1 mu2 cos theta. So by using this formula, we can calculate the resultant dipole moment. Actually, dipole moment is the vector quantity. In para isomer, in para 1, 4 dichloro, 1, 4 dichlorobenzene. So dipole moment it becomes as 0. So because of two chlorine atoms are present in exactly opposite direction. When they're present in exactly opposite direction means net magnetic net vector quantity becomes as 0. Okay, and what is another thing we can say means here, so dipole moment is depends upon the bond angle. So bond angle and dipole moment are inversely proportional. This also we can write like this here, bond angle and dipole moment are inversely proportional. Smaller the bond angle, greater the dipole moment. Okay, greater the dipole moment, lesser the bond angle also we can say. Now you got the clarity, all of you? So
Yes.
until I understood, so all these are the physical properties of haloalkanes and haloarenes. Okay, then we'll go for the chemical properties of the haloalkanes and haloarenes. Okay, chemical properties. Chemical properties. Chemical properties. Okay, so what are the chemical properties means here? First of all, here alkyl halides and aryl halides. Alkyl halides are it undergoes to the nucleophilic substitution reaction. First, I'll discuss about the chemical properties of the alkyl halides. Okay, first I'll discuss about here. So, chemical properties of alkyl halides. Okay, so what are the chemical reactions? Means alkyl halides are it undergoes to the nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic substitution reaction. Okay, and what is the second one means here? Alkyl halides are it undergoes to the elimination reaction. Elimination reaction. Alkyl halides are it undergoes to the elimination reaction. And alkyl halides are reacts with metals also. Reacts with metals. Okay, so these are the some chemical properties it is out there. And cleavage of the alkyl halide. That means here reactivity of the alkyl halides also depends upon cleavage of CX bond. Okay, reactivity of alkyl halides. Reactivity of the alkyl halides are depends upon cleavage of C bond X. Cleavage of C bond X. Okay. So in this one, let's say we have a different types of the halides are there. So what are the different types of the halides are there here? For example, alkyl fluoride is there, alkyl chloride is there, alkyl bromide is there, and alkyl iodide it is there. So if you see on this one, which one is more reactive means here, alkyl iodide is more reactive. Okay, from alkyl fluoride. From alkyl fluoride to alkyl iodide, reactivity is going to be increases. Why the reactivity is going to be increases from alkyl fluoride to alkyl iodide? Is any reason is that?
So because of electronegativity?
Electronegativity is decreases means reactivity is going to be increases or decreases?
Decreases, sir.
Sir, it decreases, right?
Decreases. Sir, how you can tell? Actually, we can't compare the electronegativity in this one here. So we are seeing the bond length. Bond length from
Yes,
alkyl
sir. If
chloride to
electronegativity is more, then the bond length will be shorter, right? Because it pulls the electron towards itself. So less the electronegativity, greater the bond length.
lesser the electronegativity, greater the bond length. If the
Right, because
greater the bond length, then whatever the bond dissociation energy will be more or less. Kathy, what is going to be the bond dissociation energy first of all?
So the energy required to break the bond.
Very good, ma. So the energy required to break the bond is called as a bond dissociation energy. Okay. Now, alkyl fluoride to alkyl iodide, bond dissociation energy is going to be increases or decreases?
sir, it will increase because it will have a greater bond length, right?
Ma, bond dissociation energy is going to be increases or decreases from alkyl fluoride to alkyl iodide?
Sir, it will decrease.
It's going to be decreased. So
Decrease.
why it is going to be decreases, ma?
So because the bond length would be weaker, because it's
Yes.
not more electronegative compared to the other, so it will be weaker and easier to break comparatively.
So bond length and bond dissociation energy are inversely proportional, ma. Simple statement. Bond length and bond dissociation energy are the inversely proportional. Okay. Greater the bond length, lesser the bond dissociation energy. Shorter the bond length, greater the bond dissociation energy. So from alkyl fluoride to alkyl iodide, bond dissociation energy is going to be decreases. So that's why from alkyl fluoride to alkyl iodide is going to be increases. And what is the another reason we are having means here? So methyl, for example, only one halide we are taking. Methyl chloride is there. Okay. Otherwise, ethyl chloride C2H5Cl or propyl chloride it is there. Okay. Propyl chloride C3H7. Okay. C3H7Cl it is there. Sir, which one is more reactive towards the nucleophilic substitution reaction? Means first one is more reactive. Methyl halide is more reactive than ethyl chloride. Ethyl chloride is more reactive than that of here. So propyl chloride. That means carbon chain length is going to be increases. Reactivity is going to be decreases. Okay. So because of polarity is going to be decreases. Polarity and not all we can explain based on the inductive effect. So while discussing the inductive effect is applicable first 3 carbon atoms only. Up to 4 carbon atoms only inductive effect is going to be applicable. Inductive effect explains the polarity of the compound. Okay. So GOC, while studying the GOC there we studied. Did you remember or not? I don't know exactly. Okay. Now, so next one. Yeah. So first we can take out the nucleophilic substitution reaction. Okay. First we can take out the nucleophilic substitution reaction. First of all, what is mean by the nucleophilic substitution reaction? Who's going to tell about the nucleophilic substitution reaction? Nucleophilic substitution reaction.
Sir, the reaction in which a nucleophile replaces the existing nucleophile in a molecule.
So how it is going to be existed? On which basis it is going to be exist? On which basis it is going to be exist? Highly reactive nucleophile is displaces less reactive nucleophile is called as a nucleophilic substitution reaction. Sir, where you studied about this one means here in 11th standard we have a different types of the reactions under types of reactions. Addition reaction, substitution reaction. At the same time, we studied GOC. While discussing the GOC, we studied about this one more types of reactions. So I didn't remember here. Okay, so types of reactions are there in 11th standard syllabus. Addition reactions, substitution reactions, okay, elimination reactions and rearrangement reactions here. Okay, in that one, again, we have a different types of the addition reactions are there. We have a different types of addition reactions are there. Okay, so again, electrophilic addition reaction, nucleophilic addition reaction, okay, free radical addition reactions are there. And substitution reaction also we have it different types here. So what are the different types of the substitution reactions are that means here? Okay, so what are the different types of the substitution reactions we are having means here? Electrophilic substitution reactions are there, nucleophilic substitution reactions are there, free radical substitution reactions also it is there. Okay, what are the different types of the substitution reactions means here? We have an electrophilic substitution, nucleophilic substitution, and free radical substitution reaction. Okay, so for that one, what is the best example? Means morning we studied for the free radical substitution reaction. Okay, I think so. Yesterday we studied preparation of the haloalkanes by the halogenation reaction. Halogenation reaction is one of the best example of the free radical substitution reaction. Halogenation reaction is one of the best example for the free radical substitution reaction. Okay, now like that only we are studying about the nucleophilic substitution reaction. First of all, what is meant by the nucleophile, which we can call as the nucleophiles?
The electron rich species.
The electron
Rich species.
rich species. Very good, ma. Electron rich species is called as a nucleophile. And is any other definition for that one? And any examples for
So
the
ones which
nucleophile?
seeks for new.
Ma? Aditi? Aditi, you are asking something. Kathy, what is the definition for the nucleophile?
So can you hear me?
Yeah, I am able to hear, ma.
So nucleophile is a reagent that brings the electron pair to the reaction site, or like it seeks nucleus.
It seeks nucleus. That is only correct only here. Nucleus seeking atoms or molecules also we can call as nucleophiles. Okay, and negatively charged. Actually, we have two types of the nucleophiles are there. Negatively charged ions also we can consider as nucleophiles, and neutral nucleophiles. So what is meant the neutral nucleophile? Means electron rich species. As per the Ritu, Ritu told that electron rich species are there, na? That we can call as nucleophiles. Okay, and negatively charged ions also we can call as nucleophiles. Negatively charged ions also we can call as nucleophiles. Okay, now so based on that one, let us see what we can call as a nucleophilic substitution reaction. Means highly reactive nucleophile is these places. So less reactive nucleophile is called as a nucleophilic substitution reaction. Here we have two types of the nucleophilic substitution reactions are there. How many types of the nucleophilic substitution reactions are there? We have two types of the nucleophilic substitution reactions. What are the two types of the nucleophilic substitution reaction? Means SN1 reaction and SN2 reaction are there. Okay, how many types are there? Two types. So one is called as a SN1 reaction, another one is here SN2 reaction. So what is meant by the SN1 reaction? SN1 reaction mechanism. SN1 reaction. So first of all, I'll give the definition for the SN1 reaction. SN1 reaction is called as a one is called as a unimolecular. N is nothing but nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Okay, so in this one here, so SN1 reaction is called as a unimolecular nucleophilic substitution reaction. Okay, I think so. We studied chemical kinetics also. Is it right? So that we studied about the order. So what is meant by the order? What is meant by the order? What is meant by the order in chemical kinetics? It's all some questions also.
The sum of the power of the concentration reaction.
Very good, Ritu. Okay, it is sum of the powers of molar concentration of the reactants in a rate law or rate expression is called as a order. Okay, so based on the power, we can call as a zero order reaction, first order reaction. Okay, now, sir, why we are calling as a unimolecular nucleophilic substitution reaction means the rate of reaction is directly proportional to the molar concentration of the reactant only. It is not depends upon the substrate molecule reagent. Okay, the rate of reaction is directly proportional to the reactant. Reactant also we can call as a substrate molecule. Okay, reactant also we can call as a substrate molecule. It is not depends upon the reagent what we are using in the reaction. According to that one, the chemical kinetics. So what is the order of the reaction means? It is the first order reaction. First order reaction. So why we are calling as a first order reaction means it is depends upon the molar concentration of the reactant or substrate molecule raised by one unit. So that's why we are calling as a first order reaction. Okay. And what is the reactivity of the alkyl halides? Reactivity of alkyl halides. Reactivity of alkyl halides. So which alkyl halide is more reactive means here. So tertiary alkyl halide is more reactive than secondary. Secondary is more reactive than primary. Okay. So according to the reactivity order, which alkyl halides are more reactive means here. Tertiary alkyl halides are more reactive than secondary. Secondary is more reactive than primary alkyl halide. Okay. Now you got the clarity. And which solvents are favors the SN1 reaction? Which solvents are favors the SN1 reaction means here polar protic solvents. Polar protic solvents are favors the SN1 reaction mechanism. So what are the examples of the polar protic? What is named the polar protic solvents which we can take as a polar protic solvents?
It gives H plus, sir.
Very good one. It gives as a H plus. That means water molecule, ammonia, alcohols. Okay. So all these are the examples of the polar protic solvents. Okay. All these polar protic solvents are they favors the SN1 reaction mechanism. Okay. All these are the favors here. SN1 reaction mechanism. Okay. Now, so let us see the reaction mechanism now here. So what is the best example we can take with the SN1 reaction here? Best example now. So here which one it undergoes means here tertiary alkyl halide. Which one means here tertiary alkyl halide. I'm taking as a tertiary butyl chloride. What is the reactant I'm taking means tertiary butyl chloride. CH3 bond CH3 bond CH3 bond Cl. When the tertiary butyl chloride is treated with the OH minus ion, it forms as a tertiary butyl alcohol. It forms as a tertiary butyl alcohol. CH3 bond OH plus Cl minus. Okay. Now HCl. Okay. Now, so this is a general reaction we are writing here. So then what is the reaction mechanism? How we can write the reaction mechanism? Okay. So reaction mechanism. Okay. So actually SN1 reaction is going to be completed into 2 steps. Total how many steps it is going to be completed means here it completes in 2 steps. 2 steps. Okay. So first one. So what is the first one means here? First step is tertiary alkyl halide. So what is the tertiary alkyl halide we have taken? Butyl chloride, tertiary butyl chloride. With the tertiary butyl chloride is it undergoes to the unsymmetrical cleavage. When the tertiary butyl chloride is it undergoes to the unsymmetrical cleavage, it forms tertiary butyl carbocation CH3 bond CH3 bond CH3 plus Cl minus plus Cl minus is going to be formed here. Okay. Now, actually, this is the slow step. What is the step it is there here? It is a very slow step. Okay. And slow step only we can call it as a rate determining step only. Okay. The rate of reaction is depends upon the elementary reaction only. Okay. In this one, which one is the elementary reaction means slow step only we can consider as an elementary reaction. So, which reactant it is involved in the rate determining step? Tertiary alkyl halide. Due to that reason only the given reaction is called as a SN1 reaction. And what are the carbocation? And it undergoes to the unsymmetrical cleavage. It forms as a carbocation and anion. Okay. What are the carbocation it is there? Highly reactive or less reactive? Charged species are highly reactive or less reactive? Is charged species are highly reactive or less reactive?
Highly?
Charged species are or fragments, reaction intermediates are highly reactive. They are highly unstable. To become as a stable, immediately they have to attach with another ion. Otherwise, they undergoes to the elimination reaction. Then only it becomes as a stable. So in the second step, what happens? What are the stable carbocation it is formed? That it is combines with the OH minus ion. That it is combines with here OH minus ion. If it is combines with the OH minus ion means it forms as a tertiary butyl alcohol. It forms as here tertiary butyl alcohol. Have you got the clarity? Still any doubt is there?
No, sir.
So this is the reaction mechanism here. And based on this one, how they're asking the questions in the NEET level examination and JEE level examination means, okay. Now already we studied about the isomerism of the haloalkanes and haloarenes. Is it right? Okay. Now my question is, in SN1 reaction 1, if the tertiary alkyl halide is optically active compound, then what about the stereochemistry of SN1 reaction? My question is, once again, I'm repeating here. In SN1 reaction mechanism, if the reactant is tertiary alkyl halide, the reactant is tertiary alkyl halide, then the stereochemistry of the SN1 reaction is, or what is the product of the what is the product of the SN1 reaction? What is the product? What is the stereochemistry of the product? Stereochemistry of the
Sir,
product.
there won't be any chiral centers, right? For like the
I'm
small.
talking about the optically active compound only, na? Question is clearly I'm giving as a reactant is optically active compound. Reactant only optically active compound, ma. But it forms as a racemic mixture. Remember one point. If the reactant is optically active, which we can call as optically active, the compound which contains the chiral center only, na? If it is having chiral centers means finally if they undergoes the optical isomerism, what is the product will get? Product will get as a racemic mixture. Okay. So in SN1 reaction, if the alkyl halide is optically active means the product is, what is the product of the stereochemistry means? Product is you will get as a racemic mixture. So why you will get as a racemic mixture means it is optically active. Either it may be undergoes to the dextrorotatory and levorotatory. If it is having 50% of the dextro or 50% of the levo means finally we can call as a racemic mixture only, na? Is it right or not?
No.
Okay, that is the question. That kind of questions are there. Okay, if you see in more material also you're having that kind of questions. Okay, and what is the reaction intermediate in SN1 reaction? Reaction intermediate. Reaction intermediate. On screen only it is there.
For a carbocation.
Very good, ma. What is the reaction intermediate in SN1 reaction means here? It is the carbocation. Okay, carbocation is the reaction intermediate in SN1 reaction. Now we got the clarity. Okay, so then can I go
Yes,
for the
sir.
next one here? Clear? Right now. I'll get that here. SN2 reaction mechanism. SN2 reaction mechanism. SN2 reaction mechanism. Sir, what is meant by the SN2 reaction mechanism means? What is the abbreviation means? This also we can call as a bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. And rate is directly proportional to substrate molecule as well as the nucleophile. Okay, in why we're calling this a bimolecular reaction means here. So rate of reaction is directly proportional to molar concentration of the substrate molecule as well as the molar concentration of the nucleophile. Hence, what is the order of the reaction in this one? What is the order according to that one? Order is equal to second only na, 2 only na. Order it becomes as a second. Okay. Now, what is the reactivity order? Reactivity order. So, which alkyl halides are more reactive means here? First, methyl halide. Methyl halide is more reactive. After that, primary. After that, secondary. After that, tertiary. So, which solvents are they favors the SN2 reaction mechanism means here? Okay. So, which solvents? Solvents favored. Solvents favored reaction. So, which solvents are they favors the SN2 reaction mechanism means here? SN2 reaction mechanism is favored by, okay, polar aprotic solvents. Polar aprotic solvents. Polar aprotic solvents. Polar aprotic solvents are called as here. Okay. So, polar aprotic solvents are favors the SN2 reaction mechanism. Sir, what is the example of the polar aprotic solvents? Carbon tetrachloride also we can call as a polar aprotic solvent. Carbon disulfide also it is a polar aprotic solvent. DMFO, dimethyl formamide. Okay, DMF. It's not the dimethyl formamide here. So DMSO. Okay, DMF is nothing but dimethyl formamide. Dimethyl formamide is an example of a polar aprotic solvent. And DMSO. So what is meant by the DMSO means a dimethyl sulfoxide. Dimethyl sulfoxide also it is an example of polar aprotic solvent because of that does not releases the H plus ions. The solvent which does not releases the H plus ions is called as a polar aprotic solvents. I got the clarity. So polar aprotic solvents are their favors here. SN2 reaction mechanism. Polar aprotic solvents are their favors here. SN1 reaction mechanism. Okay. And simple example. So what is a simple example we can take in this one? Yeah. Same. In this one we are taking as a methyl chloride. So because of which one is more reactive means primary methyl halide. Now I am taking as a methyl chloride. If the methyl chloride is reacts with the nucleophile. Nucleophile I am taking as a OH minus. Then it forms as a methyl alcohol CH3OH plus Cl minus. Now got the clarity? Okay. Then so we'll see the mechanism. Actually, the SN2 reaction mechanism is going to be completed in a single step. The reaction is completed in a single step. The reaction is completed in a single step. The reaction is going to be completed in a single step. Okay. So what is the mechanism? Okay. So in the mechanism means here, breaking of the bond and the formation of the bond, formation of new bond are simultaneously it takes place. In this reaction, breaking of the bond and formation of the new bonds are simultaneously it takes place. Sir, how we can write the reaction means, for example, now let us see, sir. I'm writing like this. H, here also H it is there, and this one is attaches with the Cl. And in this one, in this reaction, OH is attaches from the backside minus. OH is attaches from the backside. So whenever the OH is attaches from the backside, in this one, C bond, H it will be there, H and H. So which one it forms as a new bond and which one is forms as a new bond? New bond is formed in between the OH and cleavage of the old bond, Cl. Okay. So formation of the new bond and cleavage of the old bond also it takes place simultaneously. It takes place simultaneously. So after removing of the Cl minus, you will get as a product is C bond H bond OH bond H bond H bond H. Now, if you observe the first structure and second structure, how it will be the first structure and second structure? Exactly, it is in opposite direction. Okay, so exactly it is present in here opposite direction. So whenever it is exactly present in opposite direction means whatever the product we can call that we can call as a inversion product. Inversion product. So how it will look like means here it is open umbrella. When umbrella it comes outside, how it look like here? All strings are it comes outside now. It is looking like that now. So that's why we can call it as an inversion product. Have you got the clarity, all of you? All of you got the clarity or not?
Yes, sir.
Okay, sometimes they're
Yes,
asking
sir.
the differences also, ma. Okay, so until here, once you go through your notes and you can practice some questions. So tomorrow we can practice the remaining questions. Okay, so we'll continue in tomorrow class.
Thank you,
Okay.
sir.
Yeah, you're welcome, ma. So tomorrow can I take the same time? Otherwise, any additional class I can take.
Sir, I have college tomorrow.
Okay, so then as usual, ma, here. So tomorrow onwards, we are having the as usual 7:50 class. Okay.
Okay, sir.
Thank you
Okay.
all.
Thank you, sir.
Thank you, sir.
You're welcome, ma.